Okay, pre-calc, we're going to finish up 3.4 with solving logs. So how you solve a log is you first want to isolate it. So I'm going to move this 7 to the other side. Okay, and then once it's isolated, you want to convert it to its equivalent logarithmic form. Sorry, its equivalent exponential form. So this is base e. So I'm now converting the form. E to the 7 equals to x. And that's the final answer. That is the final answer, which is great. That's a pretty big number, so I think we'll just leave it there. But and also let me see what how your book wants it. It's not horrible big, so maybe actually I'll just write it. Let me see what they want though. So I do it 3 decimals. Okay, 6.633. 633. Okay, that. So again, this is the exact, and this is the approximate. This is the estimation. Okay, you can see these go a lot faster, right? I was just doing the exponentials with you and they were taking me a while, but this is just over when you blink. So let me just say it again. You want to isolate the log first if you can. Then you want to convert the form. So it's in logarithmic form here. I've rewritten it in its exponential equivalent, and then I use my calculator to estimate that. Okay, let's just try it again. Make sure you got it, okay? So first isolate, so we'll move the 3. We'll divide by the 8. Maybe let me just, it's a little easier for your eyeballs if I do different colors. Let me reduce this to a half, okay? Now the same thing here, we're at that step again. This is base e, so e to the half equals to x, and that's the exact answer. A nice way to write that, by the way, is square root of e. That looks real nice. That looks real pretty. This is the exact answer, but for the estimate, let's go ahead and put it in the calculator. So you can use the square root key, or you can raise it to the 1/2. It's whatever you like. So second, oh, this is important that we cover this. All right, now this is e to the first power, okay? So when I use the e key, which for me, do you see it? It's right here. Okay. So second e, because they want to know, your calculator will want to know, well, what's the power on the e? So what I did was I put in it. Oh, I said, okay, it's the first power, and then I can answer it. So it's 1.649. 1.649. Okay. So same idea again, right? You got to isolate. So I spent time isolating. Then I converted the form to its exponential equivalent, and then that's it. You just estimate it with your calculator, right? It's nice when something's not like a ton of steps all the time. A challenge is fun, but sometimes it's nice just to ride a little bit. All right, let's try another one. And the reason why I picked this, even though it's really similar to the other two, is that if you notice, this isn't an ln. This is a log. So this isn't a natural log. This is a common log. Okay, so the math's just a little bit different here. So again, isolate. Okay, so when we rewrite, this is a common log. It's not base e. What base is this? Good, I hear you. You're saying that's base 10, and you'd be right. This guy's base 10. You got to memorize that. And we're going to convert the form on that. So it's 10 to the 11 over 4 equals to x minus 6. And then move the 6 to the other side. This is the exact answer. Let's see what kind of numbers we're dealing with here. So 10 raised, that used the caret for that, the caret key. Parenthesis 11 divided by 4 plus 6. Let's see what kind of estimate we get on here. So we're getting x is 568.341. 568.341 on that guy. All right, so same idea. You want to isolate, rewrite the form, and I'm just stressing you got to watch what the base is on the log. I did a lot of e's, but there could be base 10, there could be base 2. You got to really watch what the base is for when you rewrite the form. That's really important. Okay, I'm going to give you one either like this on your test 2 and your final, or one or the other, but it's really important you can solve one of these that are sort of longer and more extended. So the first thing you want to do is, this is addition, which means that these are being multiplied. So the first thing you want to do is use the log properties to collapse this. Okay, you don't rewrite right away. You collapse it into one log because you can only rewrite one log. You don't want to be, you can't rewrite two logs separately like that. Now this is an ln, so this is base e, so I'm rewriting the form. Okay, e to the 1 equals to x times x plus 1. So e equals to x squared plus x. Ooh, this is really difficult. I'm going to move the e over here. Ooh, I picked a really difficult one. Does anybody know how to solve this? Anybody got a clue? I bet you do. I bet you know how to solve this. It's not friendly, but I bet you know. This is a quadratic formula. A is 1, B is 1, C is negative e. Right? It's quadratic. You need a quadratic technique. Negative 1 plus or minus b squared minus 4ac all over 2a. Okay. Yep, this one is not friendly, but we know how to do this. Negative, positive is positive for e all over 2. All right, let me just stop here for a second because this is actually what we would call the exact answer. I can't simplify the radical any farther. Like, I'd have to use a calculator at this point. This doesn't go any farther. Let me see what kind of numbers we're dealing with over here in the radicand part. So 1 plus 4 times e. And again, I have to specify that my e is to the power 1. Okay, so that's what's under the radical. And I'm going to now take the square root of what's under the radical. I'm taking the square root of what's under there, so I just had simplified the answer. Alright, so this guy here is about 3.446. Alright, so why don't we just do negative 1 plus 3.446 over 2 and negative 1 minus 3.446 over 2. Alright, so let's just estimate this. So that's would end up being, just take a 1 from there, be 2.446 divided by 2. This one would be 1.223. And that would be negative 4.446 divided by 2. This would be negative 2.223. Okay, and then those are the estimates. You have this one. You got this. All right. This is your finale. And this one is not done like the other ones, but I just wanted to show you in case you encounter this. If you notice, everybody's a log. And if everybody's a log, it's actually a lot easier to solve. You're going to use the one-to-one property on this. It's not done the way the other ones are done. So I'm just throwing this in at the very end because the solving technique on this is different. If you're a STEM major or whatever you are, you just want to see one of these. All right, this is subtraction. So when you collapse it, it's division. All right, now there's a log on both sides, which means you're going to use the one-to-one property. It means this equals to this. The inside of the left equals the inside of the right. And this only is because there's logs everywhere. Okay? It's not like any of the other ones I just did. So just like you can give a log to both sides, you can take a log away from both sides. It just has to be on both sides. All right, let's cross multiply this up. We're just going to finish the algebra on this. Let's distribute the x in. You can see it's quadratic, so therefore you want to isolate minus x here, minus x. Therefore you want to set it equal to 0, not isolate. Let me just make sure I got this right. I move the x over, I move the 1 over. All right, so as you can see, this doesn't factor, so we're back to the quadratic formula again. Oh, and there is one thing with the logs that you have to do, and I noticed I just skipped it on the last one. Let me just see if I have to do it anywhere else. All right, so let me just back up 1 second. We don't have a problem anywhere else, but we have it on the last one. All right, the thing with logs is, let me just back up for a minute. The thing with logs is you have to watch the domain, and you can't put this negative in there. It's a domain restriction. So for this last one we just did, you actually can't have this answer because you couldn't put a negative into here. So you got to watch. The logs, unlike the exponentials, have domain restrictions. So this actually doesn't work. But all the other ones, I just looked at them real quick. All the other ones we had positive answers. So there was not going to be a problem. Okay. So that one we ran into a problem, and the one we're about to do, I think we're also going to run into a problem. So just check that one of your answers may end up extraneous. Ooh, I'm glad I caught that. Let's see, b squared minus 4ac all over 2a. We're going to squeeze this in here. I'm seeing 9 plus 4 over 2. 3 plus or minus rad 13 over 2. Okay, let's pop this in the calculator. What is our radical 13 going to look like? 3.6. Okay, so we're going to run into that problem we just ran into, but I'll catch it right away this time, so it'll be clearer for you. So we have 3 plus or minus 3.6 over 2, which means one of them is 3 plus 3.6 over 2, and one of them is 3 minus 3.6 over 2. This is 6.6 over 2, which is 3.3. This is negative 0.6 over 2, which is going to be half of that, which is negative 0.3. All right, so this is the same problem we just had before, because you cannot put a negative back into the original. So this is extraneous, and you'll sometimes get those answers. This is extraneous. So the only answer we have is the 3.3. The other one you have to throw away. So try to remember, and let me just try to be really clear here to help you. Try to remember that the domain of a log is not the whole number line. The domain of a standard log is that x actually has to be greater than 0. It can't even be 0 because you got a VA at 0. Okay? And that's what I'm trying to stress here, that you can't use any x value you want for a log. If it's negative, when you plug it in, if it makes it negative, then you have to throw it away. It's not just that it's negative. It has to be like, if this had been x plus 100, when I plug in the negative 0.3, it would not have made that negative. Okay, it's like when you plug it in, overall, it has to be positive. Okay, gang, congrats. That's the end of 3.4. This a wrap. I'll catch you. Bye-bye.